Good afternoon, everyone. I'm very glad about this opportunity to share today with you my PhD research on machine learning for modeling and forecasting the ionosphere, including space weather and uncertainty quantification. This work was my PhD dissertation, which I did at Technical University of Munich, and I defended PhD last year. Before that, I completed bachelor and master degree in geodesy in Bosnia and Herzegovina, where I come from, and currently I work at the German Aerospace Center as a researcher near Munich. Let's move to my research now. Ionosphere is the ionized part of the atmosphere. Free electrons in the ionosphere affect propagation of radio waves generated by Global Navigation Satellite System, GNSS, causing signal refraction. Ionization is a result of solar radiation. Active conditions on the sun, known as space weather or solar storms, can produce irregularities in the ionosphere and further degrade GNSS signals, resulting in increased range errors. Ionospheric delay on GNSS signal can be estimated using at least two frequencies and quantified with vertical total electron content or VTEC. International GNSS Service provides final VTEC maps, as shown on this slide, with latency up to several weeks, which limits its use in real time. Such maps can be used to correct for ionospheric delay in GNSS in precise manner. Recent large-scale space weather impact on GNSS include disruption of RTK service used for precision farming in Canada and US last year. This caused significant economic losses. The storm produced colorful polar lights, also visible in Frankfurt as seen in this image. Space weather include complex and nonlinear relationships, challenging to model in traditional way. In recent years, AI application expands also in the field of space weather and geodesy. However, there is a question of trustworthiness, which requires strategies for reliable, interpretable result of an AI system. Objective of this study is to develop ionospheric models which can provide reliable and accurate ionospheric correction for GNSS and serve as early warning information for space weather impact on the ionosphere. This is achieved by defining the developing model as a function of location, time, space weather, and ionospheric conditions. Tools from machine learning were used to find this nonlinear model function, and uncertainties are quantified in form of confidence intervals to provide information how certain the results of model are and to improve trust in the AI model. Workflow starts with preparing training and test examples of solar, geomagnetic, and VTEC data. In the second step, learning algorithms were designed and implemented based on two machine learning approaches, decision tree on the left and artificial neural network shown on the top right. Training and cross-validation is performed on a rolling basis, and the models were optimized in iterations. At the end, the model is evaluated with the test data, and the resulting model provides one-day VTEC forecast and uncertainties as 95% of confidence interval. First model, Super Ensemble, combines diverse models trained on different datasets and learning algorithms from decision tree learning. They are parallel learning, shown on small image on the left, and sequential learning on the right small image. The forecasts are presented as ensemble mean value and uncertainty as ensemble spread. The second model, quantile gradient boosting, is a sequential decision tree learning that minimizes quantile error loss. By estimating multiple quantiles, we can estimate confidence intervals. Median quantile represent VTEC forecast. Third model, Bayesian neural network, is a modification of artificial neural networks where model parameters are learned as probability distribution function. By minimizing Gaussian log likelihood function, model can output VTEC forecast and standard deviation, which are used to estimate uncertainties. Let us move now to the result path for one-day VTEC forecast. Image on the left shows us that VTEC forecasts from all models are similar and within acceptable range of accuracy. Model errors are larger during solar storms. The reliability of uncertainty estimation is evaluated as the percentage of ground truth within 95% of confidence intervals. Only QGB and BNN models provide realistic uncertainties as they satisfy 95% of uncertainties. Model QGB stands out as the fastest solution, only needing 1 minute for the single test run, while other model is much slower. During solar storm period, confidence intervals are wider, and VTEC forecast is more variable, as we can see on the image on the right side. This means there are larger uncertainties. During quiet period, shown on the left image, VTEC forecast and confidence interval show similar variation and smaller uncertainties. So this is the first time that the machine learning Ionosphere models with uncertainty quantification were developed. Different approaches for Ionosphere modeling with uncertainty quantification were implemented and tested, and these approaches can be transferred also to other geodetic problems. All models perform similarly in terms of forecasting. Discrepancies are primarily in quantifying uncertainties and computation efficiency, where QGB model, quantile gradient boosting approach, stands out. And I will conclude this presentation with a list of references, my PhD thesis, and 2 journal papers, which are used for this presentation. Thank you very much for your attention, and I look forward to your question if you have any. Thank you.
Thank you, Randa. It's a quite useful topic, but specific as well. Let's see. Yes, we have one question, at least from Eugene.
Yeah, no, that's interesting research that you carried out there, Randa, and we all know that the ionospheric effect posed the greatest source of GNSS error, so it's good to see that research is carried out in this area. My question is related to the solar cycles, and I know solar cycle 25 was supposed to, or was predicted to peak this year in 2025. So has your research included the effects of this solar cycle?
Yes, that's true. So space weather follows 11-year solar cycle, where we have periods of solar minimum and solar maximum. And yes, so this now we are within a solar maximum where solar is active. So I included this effect in a way that my study includes for training data from the solar maximum period of the previous solar cycle, so solar cycle 24, when we had solar maximum in 2015. And then I was testing the model on the data set from 2017, which is 2 years after solar maximum, and I tested for the space weather storm, which happened in September, and it was one of the strongest solar storm of the last or previous solar cycle. So we took account of this effect.
Okay, that's good. Thanks for that, Nandra, and interesting research. I need to read your papers as well. Thanks.
Thank you.
Thank you. Seems no questions at the moment. So thank you, Randa. No, we have from Paul. Paul, you have? Yes.
Can you hear me? Yes. Okay.
Yes.
Sorry.
Yes.
One question: did you make some tests using your data with a PPP engine or something like that to evaluate also the performance for a PVT solution?
I heard you very bad, but as I understood, you asked me if I evaluated in GNSS applications, like positioning the models. Was that the question? Or?
Yes, exactly. Yeah, yes, with a PVT solution. Yes.
These models were not yet evaluated at this stage. Yeah, this was planned for the further work. Yeah. They were for evaluation. I used final vertical total electron maps from GNSS service, from IGS service, which are seen as accurate representation of VTEC values which can be then used to correct PPP applications. So yeah.
Okay.
So the models then evaluate in that way, but would be also interested to see, yes, in the positioning application, how they perform.
Okay, thank you.
Okay. Thank you, Randa, for your presentation. You were the last one. Yeah, good luck to everyone, but I want to thank you everyone for participating here. Special thanks goes to 12 participants for the presentations and also for the jury for their time in reading, evaluating, and participating here. I will remind participants, whatever the results will be today, and maybe you will not be selected to the awarding ceremony, but still you have gained a good experience, and I'm sure that it will give you some confidence in the future to achieve next goals. The main thing is not to worry too much about the results, because scientific works can